Yeah.
So we'll be running a little bit longer than scheduled, so please bear with me. So we covered the economic aspect. The environmental, I think, the environmental flow in waterways. We consider that if you are extracting water from any natural stream, we can't extract the whole water. We have to keep certain amount of water in that stream for environmental flow, so that the flora and fauna which is there, that can survive well. So these aspects has to be considered in the planning process too. And that information, there are certain ways of getting that information from other experts, those who are working in the stream area, based on the hydrology of that. And they can provide information that what is the minimum flow that is required, that should be maintained in that stream from where we are extracting water. So the environmental flow has to be maintained. The quality of water level of polluted the water, that has to be considered. We can't increase because of if you're discharging either treated wastewater. So the quality of that wastewater should be good enough that we are not increasing polluted flows. Change in the habitats and biodiversity of the surrounding area, that has to be considered too while planning the integrated water management process. That means whatsoever we are discharging, that should not impact on the biodiversity, that should not impact on the habitats. And also we can't take out water more than what is required for the environmental flows. The energy consumption, greenhouse gas emissions, these are other aspects which should also be taken into consideration. That means that for each and every option which we are considering, we have to see how much greenhouse gas emissions will be generated, how much energy will be utilized in providing those services. Okay? And that will help us in looking the putting in the multi-criteria assessment for those options to find the ranking of those options. And there are a number of softwares which are available for multi-criteria assessment, commercial softwares which are available. Sometimes those using Excel sheet, we can develop our own criteria and own assessment methods. In one of the papers which I will be circulating, we try to develop our own criteria, simple way, so that we can provide information to the decision makers for selecting the best option.
One software which I use combined all geographical, topographic and other features, the special multi-criteria.
Yes, yes. So there are a number of software available in the market. Yeah, sure.
It's a good software.
Yeah.
It combines technical as well as economic.
Economic and social aspect too. Yeah. I think there are one, no, I used it maybe 10 years ago, but there are a number of softwares available in the market. And social, again, looking at drinking water quality that has to be provided, degree of flood protection that is needed. Like you talked about whether integrated water management considering flood protection or not. Yes, that is also part of sanitation, reliability of supply. That is again one of the most important criteria. In many places, still we provide supply only few hours in a day because maybe the cost consideration, because of the shortage of resources. But integrated water supply system is equally bad in the sense that the chances of entering, because there are so many leakages in the water losses through the pipe network. When there is no pressure, the water start entering into the network. And that can be, there can be stormwater drainage there, the wastewater network, and that can pollute the whole. There can be so many contamination, microbiological contamination into the in the water supply system. And also the recreational aspect of green spaces. We talked about in case of looking the externalities. That is again looking the recreational aspect of green spaces, home gardening, degree of public participation in decision making. That is some of the aspect that has to be. So this community should be the part of the basically the stakeholder group.
Assigning weightage to these factors is a bigger task.
So
It comes up a lot of experience.
yes, I think
Even if you use factor analysis about it, then also experience is required.
yes.
Assigning weightages.
So in some multi-criteria analysis, you can say, okay, I'm providing equal weightage to three factors.
No, it doesn't work.
No, that's what I'm saying. It is this decision of those that group, the stakeholder. How much weightage you are giving to which, and then each, the social, economic, and environmental, they have separate weightage. Each will have few separate, and then for each you provide weightage. So there can be a good list of overall total criteria, and then out of 100, how you're going to distribute that weightage, and that depends upon which factor is more important for decision makers, what is more important for the stakeholder group, and that's why the first aspect, first activity is having a stakeholder group and make decisions about those factors that you're talking about. And that comes with the experience, that comes with the who is, normally what happens is there is one person who may be providing some guidance to the stakeholder group based on their experiences, based on what is available in the public domain, already published, and the experience of that person, provide some sort of a guidance to how the stakeholder group should operate. So under this planning current system, there are so many aspects that we have to look into. As you can see, there is a big list of understanding current system, the capacity, the water quality, what is the water demand which we are providing, and what is the demand that will be in the future, okay, because of the increase in population. Whether we are increasing the per capita water supplies in future. So all those aspects, I think there are a number of factors which you can see, the demography of that area, the climate aspect, water demand, water quality for not only for drinking water supply, but for the stormwater which we are discharging, the wastewater which we are discharging into the environment. All those qualities should also be considered. And the economic consideration means what is the cost associated. Cultural and social consideration, the perceptions aspect we talked about, that has to be taken. Institutional consideration, those who are managing, operating those systems. Catchment, wider catchment consideration, what impact will be having if you are planning indigo water management for a smaller area of a city, then what impact it will have on a wider catchment outside that area which you are planning. Starting from where water will bringing and where we discharge. So it should have consideration of wider catchment. Environmental and regulatory considerations which can be about the treatment aspect of what we are discharging. Legislation considerations, asset conditions of the existing infrastructure, whether that can be utilized or not, whether we need a replacement of the existing, it has already passed its life. If we use that infrastructure, we need to operate and maintain on a very regular basis? Who is going to fund that money? All that consideration has to be taken into while you're looking, the understanding the current system. Next one is assess system performance. So once we have looked, what are the options we are going to consider in assessing the different approaches or the options under the already defined criteria and measures. Then we'll look for the base case may be that we will provide water supply based system through the conventional centralized system. So, for example, we are providing a small extension in Roorkee somewhere, then from where the water will come. And we are providing water supply, we are providing all the services through the potable water supply which we are bringing in. And then we are discharging wastewater to the existing wastewater treatment plant. How much additional sewer line we have to lay? How much, whether we need pumping because the gravity will not allow to discharge up to that point. We may have to pump at different stages. How we are going to dispose the stormwater that will be generated over there. So it can be our base case, means we will compare other options with this base case, okay? Then we cost for all this base case option, okay, we have to bring water for 10 kilometers from outside, okay? And then we have to treat it, how much will be the cost associated with that? And similarly, discharging the wastewater and also the stormwater. So the base case is basically, we are comparing this other option with the base case, okay? The base case is defined. And the base case may also have some options of integrated water management. Okay, we can say, look, we will provide rainwater tanks in each and every home, and that is becoming our base case. Rest supply will be coming from the canal, which is maybe 20 kilometers, 10 kilometers away. And define alternatives to the base case. So apart from that base case which we have defined, what are the other options for providing water-based water services? From up to the disposal. Okay. There can be, say for example, we will say one way, another alternative is that we will utilize all that wastewater which is being generated by providing a dual water supply system. Dual water supply system is basically one line for potable supply, one line for non-potable supply on this street. So we have two water supply pipes and then two connections for each and every home. Okay. So we compare all those options, quantify the performance of the base case. Like for example, in one scenario, when we are planning for a development of 80,000 homes in Melbourne, the utility asked us to see whether it is possible to have rainwater tanks only and not providing any pipe water supply system. How big rainwater tank has to be provided? Then we did the analysis looking 10 years historical data for rainfall pattern. And then how much they provided us information that, okay, each and every home should have, each and every person in the home with a average occupancy rate of 3% per family. That was 150 liters or so. Whether it will be possible not to have piped water supply at all, and then looking for recycled water, treating at the same allotment scale, using for toilet flushing and all those things. Basically, they were talking about self-sustained systems or the houses. And then when we analyzed, we found that, okay, the reliability of rainwater tank is only 70%. That means for 30% of the time in a year, we have to bring water from outside. Okay, that means it was not practically possible. And those 30% of the days, we're not sure when those days will be there, when there is no water in the rainwater tank, because that will depend upon the rainfall pattern at that time. So the utility decided, no, we are not considering this option at all. It was more a theoretical analysis to see whether it is possible or not. Even we provided the largest tank. So after a certain capacity, if you even increase the capacity of tank, it is not going to make any difference. And that is, I think that software is talking about EcoCycle, which we will provide you. You can load on your computers and you can run it. There is a manual attached to that. You can do the analysis for just for single home. What should be the optimal size of the rainwater? So we looked that aspect too. And similarly, this is very important to see, quantify the performance-based alternative system. That means having only the rainwater tanks is not sufficient, because how the utility is going to manage the water supply system where they are required to provide water supply on a 24-hour basis. So that option was not even considered. That means this is one way of assessing the performance of the system. So it is very essential that whatever options we are considering, we should analyze those options from the operational point of view, from the performance point of view, so that we can provide water supply system for 24 hours. There is no flooding. The stormwater, the wastewater which is being collected is treated properly and disposed of, or utilized locally through the dual water supply system. And then you can compare performance of the base case and alternative, and for the decision makers. So in this case, I think I showed this diagram before too. It is just a question that you will see there are a number of alternatives options being listed in this diagram, which you can see yourself. Basically, the idea is that we can have a alternative approaches of the system using different options, which can help in overall planning and reducing the freshwater resources, which is critical for all of us, and also looking the environmental aspect of not discharging bad quality of wastewater into the receiving environment. This diagram is basically talking about assessing the performance of the overall system, which you can see over here, looking from the operational aspect. Let me show work on this one. The governance and regulations, social issues, natural environment, system infrastructure, operation and economics. So basically looking the performance of the system which we are considering from covering all aspects of basically which are either coming from the regulatory aspect or coming from the economic aspect, which we already have considered initially by having that stakeholders group, those developed objectives and the assessment criteria, and also the number of criteria for environmental social aspect. So this is just to show you that what integrated water management and water system design, they are linked together. But the common integrated water management is looking the wider overall catchment aspect of the planning, not looking just a development scale, but overall wider catchment scale, looking the overall impact of that from water sources to the disposal point. And so in that one, integrated planning includes water use, sewer, wastewater, network resource focus. But rainwater, stormwater, harvesting, flooding which is common in both. Water system design is more looking The stormwater aspect. Water sensitive urban design is focused on managing, as you might have seen the terminology which we used, is more stormwater focused. And rainwater and stormwater are linked together because the moment the water is coming down, hitting the ground, it becomes the stormwater. So the common aspect in both is rainwater, stormwater, harvesting and flooding. Otherwise, they are slightly different in the planning process because the water system design is more talking about managing a stormwater. But stormwater, because we are harvesting a stormwater, that becomes the part of the overall integrated water management planning too. The next part is the implementation aspect. Here comes the metrics. Basically, we have number of criteria, and then you put in the multi-criteria assessment mechanism. You have different values for different criteria out of 100, and then you put them into multi-criteria assessment models or software which are available in the market, or you can use your own Excel sheet by developing using the weightage of each and every criteria, and then you can find out and you can rank them based on the criteria which you have selected, basically. And then you can talk to the decision makers, okay, we considered so many options, and out of those options, this is what we have analyzed those options, this is how we have designed those options for conceptual aspect, and this is how we have analyzed giving the weightage to different criteria, and this is what ranking we are getting. And that will help them in decision making that what's option they're considering for that particular location. Every city, every every location may have different solutions which may be suitable to that particular location. It's not one solution for all.
Sir, mainly we are talking about stormwater. So if the places is precipitation dominant in the snow flooded area, the snow is the main source of precipitation. So the system maybe what is the solution for that?
So if we are talking about the hilly region where it is dominated by, most of the time it is under snow, then some of the options we are talking about even will not work there. Because the stormwater which is being generated, that is initially being converted into snow, okay, because the rain, but so these solutions may not be that much suitable. But when it is melting, so it will becoming stormwater, but the quality of that is much better than. There is in one of my presentation, there will be a lot of discussion about this stormwater quality. That can help you in taking that sort of a decision you're talking about, or it can inform you a little bit more. But water sensitive design approaches may not work there if it is the area is under snow most of the time. You have to think of some other options, but in that case, the water quality will certainly be different from the stormwater quality because it is get polluted because of the transportation, the trucks which are moving in urban areas, the wind, the dust which is coming through the wind. There are so many other issues like in Delhi there is so much fog which comes down with the rain that has so many pollutants in it. So in that case, in hilly areas, the situation may be entirely different. Maybe we have to think of other solutions, other aspects. Maybe we can discuss a little bit more to understand your question much more closely. Yeah. So this is a diagram which gives us the overall picture what we talked about so far. I have simplified in putting it very simply in this diagram, but it is overall what I have discussed so far. To make it more simple to understand, it's not that you won't be able to understand the other one, but this is the simple way of putting everything what we put in the whole book over here. So start from here, formulation of a stakeholder group, identify objectives, understand system which is already there, identify constraints of opportunities for integrated water management. There will be certain constraints too, which we should also take into consideration. Okay, we can't provide, like for example, I gave you an example that rainwater can't only be the solution for providing potable water supply system. And the collection of, then collection of data and information basically not only about the existing system, but also how we can calibrate and validate various models which are going to use in that whole analysis. So that information is also needed. How we are going to calibrate and validate our models to have a better output. And then formulation of water servicing options, and then basically the design and consultation and implementation aspect. So, and this process will go on after a couple of years' time, maybe the 5-10 years' time. You think about whether there is a change in the population, there is a change in demand, there is an industrialization process, all those things. Maybe some of the systems which you provided didn't work. So this process will be repeated again after a couple of years' time. So it is a continuous process. It's not that, not per year, maybe after 10-15 years' time. Or whenever you think it is required to say, suppose there is a very big industries coming up in that area, too few industries are coming up, and you have to think again. So in conclusion, we discussed about the framework. Planning process can vary based on the following, which can be local site, special condition, and existing services. Whatsoever we have talked, it is a very generalized aspect. And we have to consider the local conditions, what is needed for the community, the area which is there. Their requirements can be different, their paying capacity can be different, the contribution from the government to provide those services can be different. The priorities can also be different. Aim and objectives of implementation, we have to think about up to what level we want to implement integrated water management. Economic and social aspect and constraints, resource availability and willingness to pay by the community, how much they are happy to pay for those services. This is the document which I showed to you initially, and we will be providing a copy of this document, which will help to understand a little bit more what we have discussed. We will discuss about few other frameworks for assessing different options. I will give you one more examples in one of my lectures. Okay, so seems to be the end from my side. Happy for any discussion, your questions, comments, suggestions, most welcome. You are the future engineers and professional scientists, so your views are equally important. We sometimes speak from our experiences, but your experiences can quite be different. They can contribute to the overall and provide us to some learning and thinking material down So happy to take your suggestions, comments. Not today, maybe tomorrow you can discuss. If not today. Feel free to ask any question, not necessarily that I will be able to answer, but certainly, yes, we can communicate. Are you able to follow what I'm talking about, or do you want any more examples, change, thinking? Because teaching in a classroom is different. Teaching those professionals in this type of course can be quite different. So it should be more two-way process. So happy to take your suggestions, either you can come and talk to me individually if you have something more to discuss. Should we close now? If the time is okay, we'll see you tomorrow. Yeah.
Yes.